Good morning, everyone. Yeah, very good morning. Shall we begin the session? Yes, today's topic is chapter number 4, that is the processor architecture, how we can process or how we can do the things, that is how we can able to do the things, that is the processor architecture. That is Y86 instruction set architecture that defines with the logical design hardware control language, that is SCL. Then how to implement the Y86 implementation, that is architecture, what are the various general principles of pipelining, what are the various pipeline Y86 implementation, then there is a summary for 449, then bibliographic notes, homework problems, solution to the practice problems, what are the various solution that is given to the practice problems. So what are the various bibliographic notes, how we can do this one, what are the various solution to the practice problems. Okay. So let's start with the first one, that is a modern microprocessor that are among the most complex system that ever created by the humans, and the single silicon chip that is roughly the size of a fingernail can contains a complete high performance processor. Then there is a large cache memories and the logic required to interface it to the external devices. What are the various external devices that is used? And in terms of the performance, the processor implemented on a single chip today that is used with the room size supercomputer that cost around, we can say that it cost around the rupees or the dollar 10 million just 20 millions or 20 years ago. And even the embedded, when we use embedded microprocessor, that is also used in the day-to-day appliances such as cell phones, personal digital assistants, and handheld game system that is as far as more powerful than the early developer of the computers ever said. That is known as the instruction set architecture, that is ISA. Then different families of the processor such as the Intel IA32, IBM PowerPC, and the ARM of processor are the different ISA. And whatever the program compiled that runs on the another, and on the other hand there are multiple models of the processor within a single family that is used with the IA32, that is known as the ISA. Yes, international standard architecture. Now, let's see. Okay, okay. Wait. Chances are you will never design or ever design your own processor. This is a task that expertise says that is working a fewer than the 100 companies worldwide. Why then should you have learned about the processor design? First one is it is intellectually interesting and important. There is a interesting value in the learning how things work, that is especially interesting in to learn the inner working of the system that is such a part of the daily lives of computer scientists and the engineers, and yet remains a mystery to many. There are many processor design, there are many embodies, many of the principles of the good engineering practice that requires creating a simple and regular structure to perform a complex task, whatever the task that is required to satisfy the needs. Then understanding how the processor works aid in understanding how the overall system or the computer system works. That is also one of the main part. That is how the computer system works, or how it will gather, or how it will use with the processing of the task, with the usage of the task. So that is used with the processing of the information that is required with the how to or how the overall design works, or how the overall design taken out with the many understanding with the overall design work, with the main processing work that is used with the computer system, that is used with the scenario, whatever the scenario that we are using. So whether to produce with how the understand or the how the processor works aid in understanding how the overall computer system works, that is how it determines and how to perform various tasks. In chapter number 6 we will look at the memory system, and in this technique we are going to create an image of very large memory with very fast exercise, and when we see the processor side of the processor memory interface, that will make the presentation more complete, more we can say the rectify that is used with the scenario. Then although few people design processor, many design hardware system that contains the processor also. That means For example, if I'm taking out the common place that is used to the processor that is embedded into the real system, such as the automobiles, appliances, whatever the scenario that is available for the data, for the embedded designer that must understand how the processor works, how we are going to use, because these systems are generally designed and programmed at a lower level of the abstraction. That is the case for the desktop system, whatever the scenario, whatever the rules regulation that is followed, and you must or you just might work on a processor design. Processor design means what are the various internal part, that is a microprocessor that is used, that is very small, design team working on those processors that are already growing large, and there can be over 1,000 people involved in the different aspect of the major design or the major process or processor design. In this chapter, we start by defining a simple instruction set that we used as a running example for our processor implementation, that is used as a 586 instruction set, because it was inspired by the IA32 instruction set, which is also referred as X86. And when we compared with the IA32, the Y86 instruction has fewer data types, instructions, and the corresponding nodes that have a simpler byte level encoding. Still, it are sufficiently complete to allow to write the simple programs, manipulating the integer data, and designing a processor to implement Y86 also requires us to face many of the challenges that is faced by the processor design. And we can provide some backgrounds on the digital hardware design that describes the basic building blocks used in the processor, how they are connected each other, and how they are operated on a single machine, single language machine, that is known as SCL, hardware control language. Now, SCL is used to describe the control portion of a hardware system that is used by the language to describe how the processor designed, what are the various parts. For example, if I'm talking about the microchip, that is also one of the example of the processor design. And as a first step in designing the processor, we present a functionally correct but somewhat impractical. Then this processor also based on a sequential operation. The processor executes a complete Y86 instruction on every clock cycle, and the clock must run slowly enough to allow an entire series of the actions to complete, whatever the action that is used to complete within one cycle. And such a processor could be implemented, but its performance will be occupied, will be well below that could be achieved for such hardware. That means hardware is also one of the major issue that is also used with the pipeline processor, with a series of the transformation to create a pipeline processor. And this processor breaks the execution of each instruction into 5 steps, each of which is handled by a separate section of the stage of the hardware. Yes, very good. There are multiple hazard conditions where the location of the operands of one instruction depends on the other that are still in the pipelining for studying and experimenting. Our processor design, our design that includes an assembler for Y86, simulators for the running the Y86 program, simulator for the 2 sequential and the 1 pipeline processor design, that is various number of cases that is used with the testing that is SCA. Then Y86 instruction set architecture that is used to define the different state elements, set of instructions, encoding, we have multiple programming conventions, and the handling of the exceptional events. When I'm talking about the programmer or the programmer visible state, the programmer visible state that is used to define architecture such as Y86 that also defines a different state element, the set of the instruction and their encoding, set of the programming conventions, and the handling of the exceptional events. Then programmer visible state that illustrate each instruction in Y86 program that can read and modify some part of the processor state. That is referred as the programmer visible state, where the programmer, in the case of either somewhat or someone, that occupy for the writing the program, for disclosing the program, or a compiler generating program. Where the programmer asks what you do, what you need to do, and organized in the manner by implemented by the ISC. And as long as we make sure that the machine level programs also appears to have access to the programmer visible states, and there are 8 program registers. What are the various program registers? One is EAX, one is ECX, one is EDX, EBX, ESI, EDI, EXP. So these are the 6 registers or the 8 register that is available, that is known as the program registers. Then CC condition code, there are ZF, SF, OF. Then PC, then stat program status, then DMEN, that is a memory that is used with the IA32 programs for the Y86 access and modify the program registers, condition code with the PC and the memory, and the status code indicates whether the program is running normally or some special event has occurred. Now, these 8 registers are based on the 3-bit single bit condition code, that is ZF, SF and the OF, that is used with the program counter that holds the address of the instruction currently being executed. And the memory is conceptually a large array of the byte that holds a program as well as a data, and this program also references memory locations using the virtual address. There is a concept of the virtual address in the Y86 program that contains hardware programs, operating system software that translate these into the actual or the physical address space, indicates where the values are actually stored in the memory, or where and how the values are stored in the memory. That includes a monolithic byte array. Then the final part of the program is the status code that says the overall execution or state of the program execution, that is some sort of the exception that has occurred, that has attempt to read from invalid memory address that includes various instruction, various data that is used with the Y86 instructions. Yes, then ISA is also largely depends on the Y86 instruction.
I'm sorry, I've not been online all this while about the Aptech job you told me.
Yes, yes.
So I will get the link and
Now, first one is a Y86 instruction that is used, or that is used with the instruction that is used with the IA32. That is a part of the ATT format, and there are further details about the different Y86 instruction that used, or that is used with the IA32 move 1 instruction that is split into 4 instruction. One is the IR move 1, RR move 1, MR move 1, and the RM move 1. That indicates the form of the source and the destination, and this is either immediate, register, or the memory, that is I, R, or M. And these are the various registers, that is hot, knob, RR move 1, RA, RB, IR move 1, VRB, then RA, DRB, DRB, RA, then RA, RB, then destination, then C move access, register A, register B, then goal destination, that is a DEST, then RET, then push 1, perp 1. And this is designated by the first character in the instruction name, and the destination is either register or the memory. That is used by the second character in the instruction name that have, or this is identifying the 4 types of data transfer that will prove helpful when we decide how to implement them, how to use them. That is used with the 2 memory reference movement instruction, that is a simple base displacement format, that we do not support the second index for this one. For the scaling, that is used with the register in the address computation, that does not allow the direct transfer from memory to the another. And there are 4 register on the integer operation that is occurred. One is add 1, that is addition, subtraction, and XOR. And there are 7 jump instruction, that is a JMP, JLE, JL1, then JE, then JGE, then JG. And these are the taken according to the branch and the setting of the condition code, that is same with this one. And there are 6 conditional move instruction that is used. C move L1, that is move L1 means that is used with the moving part, that is used to move the data in the instructions. Then C move NE, then C move GE, C move G. And the call instructions pushes the return address on the stack and jump into the destination address. Whatever the destination process that is taken out, so that is used with the stack and and jump to the destination address, and the RET instruction returns from such a code, and the push shell pop-L instructions are implemented with the push and the pop. Now what is the difference between the push and the pop? Push stack, yes, it enters the data into the stack, and pops remove the data from the stack. So one is a push and one is a pop, that is used with the IA32 instruction, that is also known as the hit. And the IA32 instruction application program are not permitted to be one of the kind instruction set, since it causes the entire system to suspend operation.